Hi. So now we are going to discuss the network-based denial of service attacks using ICMP and UDP. For this, again, we are going to use these two machines. So Kali Linux will be used to launch the attack on the Windows server. So let's go to the Kali machine, and here the first thing that we are going to discuss is ICMP flood. So ICMP is basically a Internet Control Message Protocol, which is used by ping. So we will be using ping as a tool here, and this ping will be used to send the ping flood to the Windows machine. The ICMP works like by sending a ICMP echo request to the server, and the server sends back the ICMP echo reply. And if the machine keeps on sending multiple ping requests, ICMP echo requests, without looking into the or without waiting for the replies, the server's bandwidth can be compromised. So this is what we are going to see here today. So here I'm going to use ping in flood mode. So if I say ping -f and the name of the machine, that's ZY Windows 01. So this -f switch is used to send ICMP packet to the machine without waiting for the replies. So if I execute that, it will not show me any reply from the other machine, but it is sending the package to the Windows machine. If I go back to the Windows machine, so you can see here that there must be some packets being received from the other machine. If I go here and see the ICMP as a filter, you can see that there are so many ICMP packets which are coming from Kali Linux. So you can see here that there are so many ICMP echo requests which are coming. And if I go to the task manager and see the performance bandwidth, you can see that this is a lot of bandwidth being consumed here. So that means the ICMP flood from the Kali Linux is successful. So this is how the ICMP flooding or the ping flooding can be done by using ping command. So from here you can see that it is continuously sending the data. Here I have used IP address of the Windows machine there, and it is continuously sending the data and the ICMP package, and the Windows machine is being overwhelmed with the ICMP packets. Now if I go back to the Kali Linux and first stop this flooding, the next thing that I can do is I can send a bigger packet in a flood mode. So at this moment it was just sending 64 bytes of data, but I can also send bigger packets without requesting or without waiting for any reply. So let's do that and see how the bandwidth actually changes, the consumption of bandwidth changes. So here I'm using this command, that's ping again, but the ping is sending the bigger packets. Let me just copy it and paste it here. So if I execute this command, you can see that it is sending 65500 bytes of single packet. The size of single packet is 65500, and it is sending multiple packets of this to the machine. Let me just execute this again. Instead of writing here ZY Windows 01, I'll give the IP address of the machine. That IP address belongs to the Windows machine. let us go back to the Windows machine and see how the bandwidth consumption has been changed. So it will take a moment to reflect the original consumption, and you can see here that now the bandwidth consumption has gone way too higher, since we are sending the ICMP flood packets of very large size. So that's how the ICMP flood can be executed. So the next thing that we are going to discuss is a network-based denial of service attack using UDP. UDP is a user datagram protocol, and it's a connectionless protocol. Connectionless because it does not establish a connection before transmitting the packets as the TCP does, and there is no three-way handshaking here in the UDP. So there is a attack known as UDP flood. That what does that do is that it sends UDP packets to random ports on the target machine, and it will send multiple packets without expecting the reply, and it can also send the large packets to the target machine to again consume the resources like bandwidth on the target machine. So for this UDP flood, we are going to use hping. So here I say hping 3, and flood is for flood mode without expecting the packets, then dash dash UDP, which says that I'm going to craft packets based on UDP protocol, dash P, the port number. So here we are specifying random ports starting from port number 22, or you can start from anywhere, say 25, and we are going to send this to C Y Windows 01. Let me check if it is sending something to the Windows machine, if there are some UDP packets coming here. So I think there is a problem of IP address. So let me just stop it here. The ZY Win01 is not matching with the IP address of this window machine. Let me check its IP address first. So I say CMD and I check the IP address, ipconfig, and I'll use that IP address in that machine. So it's 172.51.17.161. So now it is sending UDP packets in flood mode to port numbers 22 and above on this machine. That's the window machine. Let's go back and see whether this window machine is receiving those packets or not. And you can see here that it is receiving those UDP packets coming from the Linux machine here. So if I click on this user datagram protocol, and you can see that there are some packets being sent from the source machine, from random ports to the Windows machines on the random ports. So let us just go back to the Kali Linux, and let us see first, before going to the Kali Linux, let us see what is the task manager saying in the performance tab. So you can see here that there are since there are more packets, UDP packets being sent here, so the consumption of bandwidth is increased. Now let's go back to the Kali Linux and send bigger packets to the Windows machine. Let me stop it here and say hping flood UDP, and instead of this port 22, I say dash D
and 45,000, which is a larger UDP packet. And let me see what is the Windows machine's performance now. So you can very well see here that earlier it was consuming some amount of bandwidth, but after this larger packets, the bandwidth has increased drastically more. So this is how the UDP flooding can be executed. So using HPing3 in flood mode with UDP as the protocol, and then you can have either various variations of this command can be used. Either you can send multiple packets starting from port number, a specified port number, to randomly different ports, or you may specify a particular amount, size of the UDP packet and send it over. So this is going to decrease the performance. This is going to deny the services of a normal user on the server, because it is keeping the server unnecessarily busy, or it is consuming the resources on the server, which will degrade the performance of the server. So this was all about the network-based denial of service attacks using ICMP and UDP. So I hope you enjoyed the learning here.